Welcome to Algebra 1 Honors. This is Lesson 8-1, Equations in Two Variables. So far, we have only studied equations that have one variable, right? Such as the two over here. We might have an equation such as x plus 3 equals 10. Okay? And when we solve it, this one, we subtract 3 from both sides, and we get x equals 7. Okay, and so our solution set here is just the number 7. On this one, when we have a square, although it's one variable, x, when we have a square, usually there are going to be two solutions. Right? Indeed, if we look at this one, we're saying, what number can we square to get 25? Well, if we take the square root of both sides, and remember that we need to do a positive and a negative number, we get 5. Positive 5 squared gives us 25, and negative 5. When we square negative 5 times negative 5, we get positive 25. So two answers here. So one variable, we might have one answer, we might have two answers. Sometimes we'll have no answers. Right, if we had x plus 3 equals x plus 7. Okay? Let's see, let's take x away from both sides, 1x on each side, and we get 3 equals 7. So this is an example of an equation where there's no solution. So we'd write an empty set like that. And then there are equations that have an infinite number of solutions with one variable. If we had x plus 0 equals x, you can see that any number that we put in there, when you add 0 to it, is going to give you that same number. So this, the solution set here, is all real numbers, all numbers. 1, 2, 3, negative 1, negative 2, 1/2, 0.5, any number you pick would satisfy that equation. Okay? Now, what we're going to look at now is equations that have two different variables. Okay? Some room here. Now, if you have, as we do over here, two variables, okay, two different variables, x and y, but only one equation, then usually you're going to have many ordered pairs of x's and y's that make that equation true. We call that satisfying the equation. So for example, our x plus y equals 10, okay? We're going to have lots of different pairs. So what we're going to do is make a little T chart there. Put x over here and y over here. And we're going to choose a value for x. And then calculate the associated value of y that makes the equation true. So if we pick a 0 for x, 0 plus what gives us 10? Well, the y would have to be 10. So one ordered pair okay, because that's what they call these answers. One ordered pair that satisfies or makes that equation true would be 0, 10. The x value comes first, the y value comes second. Just like x comes before y in the alphabet. Only by convention, somebody chose that. Okay? And then if we pick, let's say, a 3 for x, and I'm just choosing at random. I pick a 3 for x, 3 plus what gives me 10? Well, its associated y has to be 7. So another ordered pair that works, okay, that is a solution or satisfies this equation, is 3, 7. Now, what if we tried let's say 7, 7. That's an example of an ordered pair that does not, okay, that one does not satisfy our equation, because if we put a 7 in here and a 7 in here, we would get 14, not 10, okay? So you're looking for, you're going to choose X or choose Y. You could choose a value for Y, for example. Let's choose Y as 9, okay? If we choose Y as 9, 9 plus X has to be 1 in order to make our 10. So 1 comma 9 is an ordered pair that satisfies this equation. Now, if we're allowed to use all real numbers for X and Y, you can see that there are going to be many solutions, an infinite number of solutions, because I could choose a negative number. What if I made X negative 10? Well, negative 10 plus 20 will give me positive 10. So negative 10, 20 works. I could also choose fractions. I could put a 1/2 in for X and a 9.5 in for Y. Okay? So if your book gives you a problem like this and asks you to find the solutions, it's going to have to bound the problem. It's going to tell you that X and Y have to be positive numbers, for example, okay, positive integers. And then there's a limited number of solutions that will work. 1 and 9, 2 and 8, 3 and 7, and so on. Otherwise, you could find a vast number of solutions. Okay? Now, what if we have, here's another example of an equation that has two variables. And this is a very common one, and when you start driving, which you will in high school, this one will be near and dear to your heart. Okay? The speed that you go, or the rate, times the time that you go that speed, gives you the distance that you traveled. So let's say that we're 50 miles away from Walmart, okay? And we want to find values for R and T that make that equation true. We're 50 miles away. Well, if I go 50 miles an hour, it's going to take me 1 hour to get there, because 50 times 1 gives me 50. If I go 25 miles an hour, right, it's going to take me 2 hours to get there. Now, if I really creep along and I go 10 miles an hour, it's going to take me 5 hours to get there. Okay? So all of these ordered pairs, 50, comma 1, 25, comma 2, 10, comma 5, and there are many others there, make this equation true. Okay? So we're now working with equations with two variables. What you're going to learn next is that when we have two variables, we're going to have many solutions if we only have one equation. But if we have two variables, but we also have two equations. So for example, if I told you that in a barn, right, there were chickens, and horses. Okay, and in total, only chickens and horses, so in total, when we add them all together, there are 10 animals. Okay? So that means if I use C to represent my number of chickens, plus H to represent my number of horses, C plus H is going to be 10. Now, if I only tell you that, my one equation, then there are lots of solutions. I could have no chickens and 10 horses. I could have 5 chickens and 5 horses. Okay? I could have 7 horses and 3 chickens. Lots of solutions. If, however, I tell you that there are, let's see, there are 30 feet in total. So if you went around and counted the chickens' feet, each chicken has 2 feet only, and counted the horse's feet. Each horse has 4 feet only, okay? And there are 30 of them. Counted all the feet. So now we have the number of chicken feet is going to be 2 times the number of chickens, plus 4 times the number of horses is how many horse feet there are, equals 30. Okay? And what you'll learn in another lesson is how to actually solve this. And there's only one solution to this. If you only have that there are 10 animals, there are lots of different possibilities. But if you add another constraint, not only are there 10 animals, but there have to be exactly this many feet, so you add another equation, then there's only going to be one solution. Okay? And sometimes there might be no solution at all. All right? And that's what there is to equations in 2 variables.